Problem 10.14, they want us to find the convolution. The first problem, h1 of n and h2 of n, they are equal and is given as 0.9 and u of n. Put it into convolution definition, then we have y of n equals h1 and convolution of h2 of n, then that equals summation k goes from negative infinity to positive infinity 0.9 k u of k and 0.9 m minus k and u of n minus k. Now that equals, we can take care of this u of k as a lower bound because u of k looks like this. And then we're going to take care of the upper bound from here because u of n minus k, here is the n, and we cover negative side. Then summation k goes from 0 to n, and we have 0.9 k times 0.9 n and 0.9 negative k. The middle 0.9 to the n, the variable is n, so we can take out to the front. Now we have a summation k goes from 0 to n, and this 0.9 k and 0.9 negative k, that'll give us 1. Now for this, we go from k equals to 0 to n, and we're gonna add 1. So that is 0.9 times the power of n times 1 plus 1 plus 1 plus 1 plus dot dot dot. The first one is when k equals to 0. Second one, k equals to 1. Third one, k equals to 2, and then it's gonna go forever. Then we know when we need to stop, we know the value of n. That's gonna be n, counting 1 through n, and then we have 1 extra right there. Therefore, that is 0.9 n times 1 plus n. And then part B, we have a h of n equals to h2 of n equals to delta n minus 2. And when we do the delta convolution, as we discussed in class, we're going to take 1 inside of the bracket and put it into the next one. Therefore, it is n minus 4. And for the part C, we have h1 of n equals to h2 of n equals u of n minus 1 minus u of n minus 3. If you are using the definitions,
y of n equals summation k goes from negative infinity to positive infinity, u of k minus 1 minus u of k minus 3 times u of m minus k minus 1 minus u of m minus k minus 3.
Now, when we look at this portion, we have this is u of k minus 1, and then we're gonna have u of k minus 3, and if you subtract that, we end up getting this. Therefore, we're gonna say y of n equals, we're gonna use this as a upper bound and lower bound. Then summation k goes from 1 to 2. Now we have u of m minus k minus 1 minus u of m minus k minus 3. Now let's plug in values. Then u of n minus 1 minus 1 minus u of n minus 1 minus 3. When you plug in k equals to 1, plus when you plug in k equals to 2, u of m minus 2 minus 1 minus u of n minus 2 minus 3. That is u of n minus 2 minus u of n minus 4 plus u of n minus 3 minus u of n minus 5. For the first part, we have u of n minus 2, which is starting with 2, and we're going to have 2 and 3 because we're going to subtract from 4. And then for the second part of the graph, we have u of 3 and 4, and then we're going to subtract from 5. That's all we have. So that is, if we add these two, now we're going to have y of n equals 0, 0, 1, 2, 1, and this is our 0. So we have 0 when n equals to 0, we have a 0. When n equals to 1, we have a 0. When we have n equals to 2, we have a 1. When we have n equals to 3, we have 1 plus 1, which is 2 now, and then 4 equals to 1, and then that's it. And if you want to use tabular method, we're going to have h of n, and h of n, we have 1 and 2, so we have a 0, 1, 1, okay, so this is 0, 1, 2, and same thing is going to happen, 0, 1, 2, sub n, and this is n, this is n. Then this portion is going to be 0, 0, 1, 1, 0, 1, 1, and this one is 0 as a diagonal because that's the where we have 0 and 0. And then we have a 0 for 1, 3, and 4. Therefore, y of n equals 0, 0, 1, 2, 1. And this is our 0.